In this video, we're going to continue our examination of multiple regression analysis, and we're going to pick up here and conduct our regression analysis again, except this time we're going to include two predictors for our regression model, once again here with life expectancy as our criterion variable. So I'm going to go back up to data. I'm going to go to data analysis. And I already have regression highlighted here from our previous analysis, so I'm going to hit OK. Now, all of the other items are still saved as long as I'm still, as long as I have my Excel sheet, my Excel file open. But what I need to do here is I need to amend my X range. So I still have the criterion variable as the outcome, but I need to delete these. So I'm just going to highlight and delete. And now I'm going to go back to my Excel sheet and I'm going to highlight graduation, high school graduation rate, and income level per month per person. And I'm going to enter both of these into the regression model. And once again here we have our output, and let me just expand the view. And I'm just going to pull open these columns so we can actually see what we're trying to capture. Okay, so as indicated as it was with the previous video, we have our R-squared value. And we have our R-squared of 0.34. Let's contrast that with the previous regression analysis where we had a very similar R-squared value. So the inclusion of an additional predictor did not seem to improve the R-squared value. So we have 0.338975. We have 0.33967. So a very mild improvement in the R-squared value when we added in a second predictor into our model. We have our ANOVA table, and the ANOVA table indicates that the prediction of life expectancy from the two variables is still considered to be statistically significant with an F ratio of 12.1. Once again here, when we examine our F ratio, anything above 2 or 3 is likely going to achieve that statistically significant level. And we have our coefficients for the y-intercept, for our y-intercept at 65.88. And to compare that to the single predictor value of 65.7, we have this value slightly changing, and it will slightly change because we do have an additional predictor in the model. We have the slope for our high school graduation at 0.100, and the slope for the inclusion of income, as you can see here, is very, very small and is actually quite indistinguishable from 0. And that's why the t-statistic associated with the income predictor is very small, giving a very large p-value. So the income predictor, when combined with high school graduation in this two predictor model for the for life expectancy, the income was not found to be a significant predictor when combined with high school graduation. And that's evidenced in the fact that the R-squared value did not increase very much. So that ends this video, and in the next one we'll throw all three predictors into the model.